right, good morning, e-learners. The other students are taking a quiz right now. You will take your quiz, well, if you're not live here, you will already have the link. So you will have 10 minutes to take your quiz as well too. Make sure you look at the symbols on question number 1, the statement there in kind of gray. Yes. Just take your A and move out. Yes. That sounds good. Got 5 minutes left. 5 minutes left. Yeah. Say again? Sure. Yes. Right now, yes. Chris, you still working? Okay. Hush. Hush. One minute left. Hush. All right, let me have that. Yes, no, maybe. Yes, no, maybe. That last one, right? Yep. That. Yep. Yep. Yep.
Two? That was my original answer too.
Yep. No. I said, yep, you got the last one right.
I knew it. We're supposed to take 2 and 12 and divide it.
All right, got your homework. All right, any questions on the homework? Once again, we're in panic mode if we can't do the majority of the reasons. We're not in panic mode if we can't get most of the statements. Now, you didn't have that many statements to do. Questions? All right. I'm going to throw out question number, which one was it? 14. 12, I didn't want you to do it because I don't want to get you in the habit of saying, I got to have a protractor, even though it literally says use a protractor. Most of geometry, or the geometry that I teach, is all logic-based. We don't measure things. We use the information to come to conclusions. All right, so let's see, we had 1 through 14 all. Here we go.
Let's just skip 14.
Right, but I'm just reading what it says. All right, here we go. Get your homework out. Let's go. Number 1, that's straight up the definition of the midpoint. If you use the theorem, remember the theorem says that this segment is a half of the other. If it doesn't say that this segment is a half of the other or 2 times the other one, then it's not the theorem, it's the definition of the midpoint. All right, number 2 is a definition of a bisector. Once again, if it doesn't say that this angle is a half of that angle, then it's not the theorem, it's just the definition. Number 3, definition of a bisector. Number 4 is the angle addition postulate. You saw that on the test or quiz. I'm recording this, forgot. Dang it. All right, give away free answers to the e-learners. Number 5, definition of midpoint. Number 6 is the first one that's actually the midpoint theorem. Notice number 6, it literally says, if D is the midpoint of BC, then BD is equal to 1/2 of BC. Right, bless you. Go use some hand sanitizer. Number 7 is the angle addition postulate. Number 8 is the segment addition postulate. I believe we did 9 in class, yes? Yeah, but the answer is 60 degrees. Number 10 is 75 degrees, and number 11 is 70 degrees. So I'm throwing out question 12. We're picking up on 13. And I believe we did A and B in class for 13. If you forgot, 13A is 12. 13B is 28. So the 2 that you had for homework was LY, C, and D. So let's see, LY is 6, and D is 22. And I'm going to throw out question 14. I believe that there's a mistake in question 14 because it starts talking about N, and it never defines where N is.
It actually gives you a hint of where N is.
You can take a guess, but it's not very stringently written, so I'm going to throw that one out. All right, Matt, collect that for me, please.
Not figure out MS14.
Well, I tried to help a couple students after school, and I was like, wait a minute, where's N? Ooh, important, big class today. All right, we just took the quiz. We're going to do about 3 things today.
They were in my notebook proof.
We're going to do about 3 things today. They are all critically important today. All right, here's your homework for tonight. Remember, if you can do the skills, you can get a C in my class. The skills so far is to be able to calculate segment distances. You have one question on that on the quiz. And angle measurements based upon the midpoint theorem and the angle bisector theorem. That's the only skills that we had so far. Today we will get 3 more skills. So for those of you that are aiming for, hey, I just need to pass geometry and I'm done with geometry, and the 3 skills that you need to pick up today are, well, 2 of them you already know. You had a good pre-algebra teacher, and by the way, I was your pre-algebra teacher, so I know that at least half of you already know 2 of the 3 skills. The 3rd skill, if you were paying attention, we actually did it also in pre-algebra as well too. So technically, I'm not teaching you anything new today if you had a good pre-algebra teacher. All right, here we go. 1 through 23 all. Here we go. So this is called special pairs of angles. It'll be okay, Matt. You can always walk up to the board too. Special pairs of angles. There's going to be lots of these. Today we're going to learn 3 of them. I've never actually counted how many of these there are, but I'm guessing there's somewhere around 10 of these that are called special pairs of angles. There's lots of them. We do the 3 easiest ones today. Here we go. And by the way, you're supposed to already know this. We'll see. All right, in your book of truth, not on the sheet of paper in front of you, in your book of truth. The first type of special a pair of angles, they're called complementary angles. Remember this? Complementary. Hey, Micah, you look nice today. What did I just give him? I give him a compliment where it's spelt with an I. Compliment. What does complement with an E mean? So I'm going to give you an example of using that word in a non-math setting. Complement. I just gave you the other complement with an I. What's complement with an E?
Is it like help something?
Help something? No. I'll be completely sexist and say, come on, ladies. You've used this word before. Compliment.
Do the dishes.
She's giving me evil eyes right now. Your shirt matches your socks. She doesn't have socks on, but that's a compliment. Am I saying you look nice? That's the compliment with an E, and that's the one
Exactly what I said.
they go with each other.
Yes.
Compliment with an E means things go together. So complementary angles, those are 2 angles that go together. That doesn't mean they're next to each other necessarily. They could. It just means they go together. And mathematically, we say they add up to 90 degrees. Those are complementary. Remember doing this a couple of years ago? No? Okay. You have 2 angles, and you add up their measurements, and you get to this magical number 90. We call them complementary angles. So here are the 2 pictures. If you need to draw them, draw the pictures. Are these angles adjacent to each other? Adjacent means next. Are these 2 angles next to each other? So here's 2 adjacent angles that are complementary. How do I know they're complementary? If I add this one to this one, I get to that magic number 90. Right? The 2 angles don't need to be next to each other. I haven't told you what this shape is yet in geometry. I know you know. But here's an angle that's 45, and here's an angle that's 45. These 2 angles are not next to each other. Right? In the case of me, literally, they share a common vertex and a common side. They're not next to each other, but they both add up to 90 degrees. Complementary angles. Yes?
Yes.
If I give you one angle, can you tell me its complement?
Yes.
How would you do that? Hey, one angle is 20. What's its complement? How did you do that? 2 ways of thinking about it. Either what added to 20 is 90, or so the book is going to do the second way. They're just going to say subtract the given angle from 90. I don't care if you think about it as addition or subtraction, either way. This is not a geometry skill. This was a pre-algebra skill that you learned. They gave you one angle and they said, what's its complement? Okay? All right. Second special angle pair is called a supplementary. angle. These two angles add up to the special number 180. Now, why 90 and 180? Well, 180 makes a straight line. 90 makes a right angle, corner. If you look around the room, what do you see everywhere? I see right there 90-degree angles. I see on Chris's book, not depression, but I see 90-degree angles. For some reason, human beings like 90-degree angles. I don't know why. Why not 85 degrees? 85 degrees gets no love, but 90 degrees gets lots of love. This entire room is just filled with 90-degree angles.
85 degrees would do that to the
I know, but I'm just saying that we like 90-degree angles. All right. Just like complementary angles, supplementary angles do not need to be adjacent to each other. Now, here are two that are adjacent. Of the two, supplementary, complementary, supplementary angles you will see more of. Why? Because when you put these two together, you get this nice straight line right here. Okay? They do not have to be next to each other. Right? Here are two angles, and well, we haven't talked about the shape yet. But 80 and 180 add up to 180. I said 80 and 180. 80 and 100 add up to 180. And here are two angles that are not adjacent to each other, but they are supplementary. Okay? Stuff that you learned 2 years ago in 8th grade. You might have seen it in the 7th grade as well, too. Supplementary, complementary. All right, that's not that bad. So if I give you one angle, how do you find its supplement? 20 degrees, what's its supplement? What's its supplement?
160.
Well, how did you do that? So she's Mrs. Add, he's Mr. Subtract, right? So either way works. What added to 20 is 180, 160, or 180 minus 20 is 160, subtraction. The book likes subtraction, not because it's better, right? It's just different. So here's what you'll have tonight for homework. Box 1, look at box number 1. They will give you 3 different angles and ask you to make the complement and the supplement. So I will bore you with this. Let's see. It says M, meaning measure. The measure of angle W is equal to 30 degrees. What's its complement? So Bailey is add. What added to 30 is 90. That would be. And Seth is 90 minus 30 is 60. You get the same answer. So this is how the book will write it, but you can certainly do addition. Okay? So this complement is 60 degrees. What's its supplement? How did you do that quickly?
Add.
So what did I tell you of day 1 and day 2 of geometry? The math in geometry is
Easy.
very easy. If you want to use a calculator, I don't care. The math that's going to be the math. We don't do hard calculations, except for trig. We don't do hard calculations in geometry. So its supplement would be 150. We okay? Uh-oh, weird. Now it says X. Chandler, what's its complement? And now, Bailey, you have to bow to the gods of subtraction.
I don't bow to anybody.
If I tell you the degree is X, what's its complement? Yeah, that was a hard one, right? So how did we find the complement over here when I told you it was 30? Yes. How did Seth find the answer?
Well, subtract.
So we're going to subtract. So what am I going to subtract? How do you find any complement? Complement.
90.
Okay, so I'm going to do the same thing. Just instead of writing 30, I'm going to write. It's not very satisfying, but that's the answer. You're like, well, what's the answer? I don't know, because I don't know what X is, but that's its complement. You got to be comfortable with that. So Bill, you have to do it this way for this one. You could certainly do adding for that one, but this one you have to say it's 90 minus X. Okay, Bailey, what's its supplement? What's its supplement? You got it. We okay?
Yeah.
What?
Seth should lose his point. He didn't give me a sheet.
You should lose a point because I'm 5 minutes into the lecture and now you're telling me this.
My hand has been up for like 7 hours.
All right, I lose a point. Okay, I don't want to make things any more complicated. Madison, what's the complement of 3x? Yeah, it's that simple, right? Don't overthink this. It's just 90 minus whatever you're given. And its supplement is 180 minus whatever you're given. So we didn't see this in pre-algebra. We saw that in pre-algebra. Now, since you know algebra, they can throw some algebraic terms in here.
Oh, yay.
Okay? Tonight for homework, there might be a few of them you have to solve for x. Right? But you know that complements add up to 90, right? You know that supplements add up to 180. No? Okay. We do on the vertical angles, the next one. Okay, we ready? All right, so that's not too bad. Complements and supplements. This is big. I mean, it is big. It is big.
No.
Now, we use the substitution property nearly every proof we do. The one that I'm about to show you, we will use frequently, not every proof, but we will use this one frequently. And you have been exposed to this before. So I'm going to show you another thing that we will use. But in order to show this to you, we are going to do a proof. There's a mistake on my paper that I handed out. On box number 2, at the very top, where it says given, write that angle 1 and angle 3 are vertical. All right. So I want you to put this definition in your book of truth before we do the proof, though. You may or may not remember this from pre-algebra. Hey, what shape do you see right now? We're in geometry.
2 rays.
I see 2 rays. This could be 2 segments, 2 lines, 2 rays, or a combination of it. But what's the basic, I'm not asking for math words, what's the basic shape you see right now? What's the basic shape you see? I'm not asking for math stuff. Visually, with your eyeballs, if we weren't in geometry, you'd say, what do you see? I see a cross, I see an X. Miss Shanklin, my geometry teacher, this is what she did. She drew that on the board and she goes, what do you see? And we all did the same thing. Oh, I think I see 2 rays. She's like, no, what do you see? I see an X or a cross, right? How many angles do you get from that X across? I get 1, 2, 3, 4. I get 4 angles. I named them 1, 2, 3, 4. There's no specific reason I named the top one 1. Any of them could be 1. When you make an X, how many angles do you make? You get 4 angles. Do you see how they are? There is a relationship between 2 pairs of those angles, right? There's a relationship between the top and the bottom and the left and the right. And I don't mean literally, it's always a top because I can turn that X a little bit and then there's not a top or bottom, right? There's a left, right, and upper left, upper right, that sort of thing. But this relationship, so somebody give me a non-math word to describe the physical relationship. Like the 2 angles, the red ones and the blue ones are what to each other? I'm not asking for a math word, I'm asking for a regular word. Next to, yeah, they're not next to each other. They're what? One more time. We'll get there. I want non-math words. They're across from each other. The thing that makes a cross, the angles are across from each other. So we're talking about the angles that are across. Sometimes kids will say the ones that are opposite each other.
I credit my answer to Mike.
Are you with me? I'm talking about the 2 red ones, and they're different from the 2 blue ones. Visually, notice the 2 red ones are acute, and the 2 blue ones are obtuse. Do you see that? Okay. Anybody know the names for those angles? You remember it from pre-algebra 2 years ago?
Obtuse and acute.
We're not going to use that. Nobody remembers this? It is the worst named angles of ever. You're like, well, complementary supplementary are pretty bad as well, too. Yeah, but they're words, and you don't really get much meaning from them. I'm going to give you a word that will cause you problems.
No.
Right? Wouldn't it make sense that we call these opposite angles, angles that are opposite each other when they're forming? They're not called opposite angles. They're called literally vertical angles. Write this down. The blue ones do not look like they're vertical of each other, but they're called vertical angles. These are angles that are formed when you make an X or a cross. Right. These angles, and then literally in the definition it says they're opposite of each other. So why don't we call them opposite angles? It's because in math we say opposite The opposite of 4 is -4. That's why we don't use opposite angles. They're not adjacent. Adjacent means next to each other. They share a common vertex, common ray. These are angles that are formed by an X, and they're across from each other, opposite.
So literally for your definition, just put vertical angles, aka opposite angle.
Right. Now, the reason why I wrote big, big, big is because we will use vertical angles very frequently. Very frequently. Madison, do you remember this from pre-algebra? Because Madison said those angles are the same. Is she right? She's saying that the red one equals the red one. The blue one equals the blue one. That's true.
But we don't have any.
Okay. Let's see if we can prove that. Let's see if Madison is right. We good? All right. Box number 2 is a proof. Change this to angle 2. I'm sorry, to angle 3. Change angle 2 to angle 3. I don't know why I made a mistake there. So on your proof, you're given an X. You're given 2 of the angles, 1 and 3, and you're asked to prove that 1 is the same as 3, congruent, right? Congruent means their measurements are equal. So we're asked to do exactly what Bailey took a guess at, that they're the same. All right? I'm sorry, Madison. All right, so Bailey, how do we start a proof? With a given. All right? Amaya, how do we finish a proof? Don't overthink this. How does the proof always finish? Okay, that's true. I was looking for the proof will always be your last statement. Maybe I should have said that then. So your last statement will always be the proof, right? Hey, look how much space there is in this proof. Hint, hint, hint. That means we're going to do some work here to prove what Madison believes. All right. What does the last statement actually say? Up till now, there's only one way to show that 2 things are congruent. You didn't catch where I said change that? Okay. All right. What's the only way that we know right now to show that 2 angles are congruent? No, well, it's there, right there. But I'm saying, what's the only way that I could prove to you right now that 2 angles are congruent? We're going to have some other skills later on this year.
Tick marks.
Okay, if I gave you tick marks, but I'm saying we don't have tick marks. So what's the only way to show that this angle is the same as this angle? A measurement. That doesn't say measurement. That says angle 1 is congruent. So the previous step, the only way we're going to get from the previous step down here is if I show you that 2 angles are equal to each other. Yes? So you guys, I've talked about this before. You know, you do one of those maze things. There's 2 ways to do it. You start at the start, or you start at the end. I don't know if anybody starts in the middle. So here's one where we're going to start at the end, because I know what the previous step would be. That has to be the previous step. I need to show that the measure of angle 1 is equal to the measure of angle 3. If I show you that their measurements are equal, what allows me to say they're congruent? Well, that's write this down, the definition of congruence. The definition of congruence means that 2 things have the same measurements. So here's one where I'm already done. I can almost already write QED on it because I know how it must end. This doesn't happen all of the time, but here's one where I can at least get one statement above from the very end. Does everybody follow that logic? The only way I can say 2 things are congruent if their measurements are equal. So that must be the previous step. I don't know what goes here, but I do know that it has to end this way. Okay. This one's hard, but let me see if I can explain it to you. All right. One thing that you can always do in a proof, you're listening, is label things that aren't labeled. What do you notice that's missing from our picture? What? I'm missing the names of these 2 angles, right? They didn't tell me the names of these 2 angles. You are allowed to name anything you want. You want to call that Fred and Bob, you can. But it would probably be better to call it the same way, like 2 or 4 or something like that. I'm going to choose one of these angles. Doesn't matter which one. I'm going to choose this angle. I'm going to name it 2. Right? So this is called label angle 2. Right? I'm just going to say that's now angle 2. Make sure you're staying with me. What allows me to label? Well, it's called the label rule. I just made that up. You are allowed to label anything you want. You're just labeling. I'm not making any claim that, oh, it's this degree, or it's congruent to this, or it's equal to this. I'm just saying the name of it, since it's not labeled, is now called angle 2. You got to stay with me and stay focused. You will not get the how to do proofs unless you stay. Every time I do a proof, you're with me. This is a hard proof, right? You've never seen that before. You didn't even know you could do that. Now you do. So now I got angle 1, 2, and 3. Like, why do I name angle 4? Well, maybe we need to, maybe we don't. Now I'm gonna show you the magic hint to this. You ready? I'm gonna cover up angle 3. Maya, what can you tell me now about angle 1 and angle 2? And make a straight line. Yeah? I need to get to something with an equal sign. She just told me that 1 and angle 2 make a straight line. Can you give me an equation now?
1 plus 2 equals 1.
You said 1 plus 2 equals 180. Is that true? Right? Because they form a straight line. Let's write that down. The measure of angle 1 plus the measure of angle 2 is 180. Oh, and I take my magic hand and I cover this up. Now what can you say?
Measure of angle 2. Or measure of angle 2 plus the measure of angle 2.
I'm making 2 statements here. That's kind of how you get this proof done. From now it becomes very easy. So how did I know to do that? That's the thing about our geometry. How did I know to do that? Well, one, this proof was shown to me when I was your age. Now I know how to prove this. If I hadn't known that, I'm not sure if I could have done this. I wouldn't have known what to do. What allows me to say this?
Angle addition postulate.
You could say the angle addition postulate. You could also say the definition of a straight angle. Either one of those. I think I said angle, or you could say supplementary angles, right? 2 angles that add up to 180. So you could say the angle addition postulate. You could say the definition of a straight angle, or you could say that they're supplementary.
Why is this so easy?
Well, because that one statement, there's lots of reasons. You have to say one of them. Are you with me logically where we're at? Okay. Karis, it's you. What does this say? What does that say? So guess what I can do now? Say it again. I can do a substitution. If 2 things equal the same thing, this is either transitive or substitution. If this equals this, and this equals this, he's 180. This equals this equals this, then these 2 are equal to each other. Or you could say substitution. This is a transitive one, but for me, I'm always just going to write substitution. So this, which equals 180, and this would equals 180. That means these 2 are equal to each other. Write that down. Why is this not clicking?
You turn it off.
I didn't turn it off.
Is the battery off?
I don't know. No, it's click, darn you. There we go. We okay? You follow that logic? Karis is officially the substitution person. Now, transitive will work as well, too. Oh, there's no space between this one and this one. That must mean I'm done. Connor, look at this statement right here and this statement here. Tell me what I did. So what did I do mathematically? Not substitution. Connor, if I wrote this, 10 plus 1 equals 10 plus 1, and then I wrote 10 equals 10, mathematically, what did I just do? I subtracted what from both sides? So what am I doing in this proof? That's what I'm doing. I'm doing a subtraction, and boom, you're done, QED. Quod erat demonstrandum, that which was to be shown. That was a lot of work. What did we actually do? How do we start this? How do we start this? What's the statement say? If I have vertical angles, what can you say? So Madison was right. Vertical angles are congruent. We just proved it, right? Write this down, Book of Truth. This is Theorem 2.3. This is used many times. Vertical angles are congruent. Theorem 2.3 says two things. Well, it's not much. It's just one little tiny statement, 4 words. Vertical angles are congruent. One, you got to remember what vertical angles are. Angles that are formed with an X and that are opposite each other. It doesn't mean up and down. It could mean left and right. Guess what it doesn't mean? If I name this angle 2 and angle 4, Chris, does 2 equal 1? No. But it does mean that 2 equals 4 and that 1 equals 3. So it's not that all 4 angles are the same. It's that the ones that are vertical are the same. Top and bottom, left and right. It also says this. If 1 and 3 are vertical, that means that 1 is congruent to 3, and it means their measurements are equal. You get to now, because of this one theorem, say those 2 things. If you got vertical angles, that means their measurements are equal. If you have vertical angles, that means they are congruent. You get to make those 2 statements. So I start off by saying C's means you can do the skills. A and B means you can do a proof. We just did a proof. That's a hard one. But you should be able to use this now in a proof. If you have vertical angles, guess what you can say immediately? If I give you a proof and you get an X, guess what you can say immediately? You can say that the 2 angles are congruent. I'm going to give you a proof and there's going to be X's. So anytime you see an X, you can immediately say, oh, look, vertical angles, they're congruent. Hey, check it out. What can you tell me about this angle and that angle? We're going to see this often. You get this hourglass shaped thing. And these 2 angles right here, you can immediately say, oh, those are equal. They are congruent because they're vertical angles. Okay. You got to be careful, though. You see this? Is any gun going to mess up that shape right there? Which angles are vertical? This one and this one, this one and this one. You want to know the one you're going to make a mistake on? That's geometry. Yeah. This is pre-algebra. You got a shape to look like this. This is geometry.
What is that?
Kids understand vertical angles all the time, but they're like, they give you a shape like this and they say, well, where are the vertical angles? Be very careful. If you have to take your fingers or a pen and darken the lines to see which ones are vertical, it's hard to visually see. Where are the vertical angles now? Well, this one right here doesn't even continue through. So this angle has no vertical angle. This angle has no vertical angle. But check this out. I need to do this for my e-learners. That one and this one, we do get vertical angles. But it's and we got another one as well too. I don't want to make too many dark lines. But this angle right here and a combination of this one and this one are the vertical angles. This one right here, a combination of this one and this one, and this one and this one are vertical angles. And then the little tiny skinny ones. Point being, tonight for homework, they're going to give you an ugly shape like this, and you're going to have to find the vertical angles. So be careful. Be careful. All right. So you see ugliness? Right? So here we go. We left off with cadence. Everyone look at box 3. What's vertical to 5? Which one? 2. What's vertical to 1? Madison? 4. And what's vertical to 6? Wes?
3.
Well, it doesn't look like you guys have a problem with that, right? Every year when I grade papers, then people pick the wrong angles. All right. Well, that was easy. So it gets a bit more complicated. Now they're going to give you measurements. We got to finish this even if the bell rings. All right, here we go. Hey, how big is angle 1? What I would do with your pencil, lightly in your book, put a 30 right there. Yes? Well, that wasn't too hard. Hey, what's vertical to angle 1? So therefore 4 must be also, you with me? Because they're vertical, so I can label that 30. You're doing this lightly with a pencil.
That means
Hey, 6 is 110. What's vertical to 6?
3.
So that means 3 is. Stop me if I'm going too fast. What the heck is 2? It's not even labeled.
Wait, no.
How big is angle 2?
No,
I'm going to take my
110 plus 30.
I'm going to take my magic hand and cover up everything except that. What shape do you now form? Then move the thumb out. It's a straight line. See the straight line? So therefore 110 plus 30 is, therefore 2 is, okay, you got this. I do want to show, sit, we're not done. One last thing is this. They're going to give you an ugly thing that looks like this. What can you tell me about this angle and this angle? Different or the same? Because they're vertical angles. So how do I solve for x here? If they're the same, that means they're equal to each other, so you can literally set them equal to each other. And then solve for x. Yes?
Oh, wait. Oh, we're solving for x.
Correct? Right. Now, the question can be written 2 ways. Sit, sit. Sit.
Let me get this on.
Okay, but make the action like you're trying to sit. Thank you. All right. The question can be written 2 ways. It could either say solve for x, or it could say, how big is this angle right here? Well, that's easy. It's 65. Right? But usually this will also be a variable. Right. All right. Questions on anything we did? All right. Let's get out.
Gotta get it going.
Who didn't copy down their homework? Here he is. Jenna, yay or nay? What we did today?
So fun.
Good. All right, e-learners, if you have any questions, make sure you ask me. Send me an email, and if you're having issues with Microsoft Teams, also send me questions. Let me help you out with that.